Friends, welcome to this channel, Dr.ARM's Chemistry. So we will see how these organometallic compounds are synthesized. So there are, so we will show here synthesis of organometallic compounds. So they are synthesized by following or using two types of methods. So they are prepared by using two types of methods. So in the first method, the organometallic compounds are synthesized by using the metal in the elemental state. So we will show here from elemental method, and second is from reactions, of already formed chemical compounds, So these are means we have divided all synthetic methods of organometallic compounds in two categories, in which the first category shows that the organometallic compounds can be prepared by using the metal in the elemental state, and second is by using the reactions in which the compounds are, means instead of elemental state, the metal can be used in the compound form, in the form of chemical compounds. So by using, in such cases, we can have a lot of stock of reactions. So we will see these types of reactions is from elemental method. So there are following types of reactions which are used here in the synthesis of organometallic compounds. So it involves the first type, that is a preparation of Grignard reagent. Similarly, we can also prepare the organometallic compounds of lithium, which are called alkyl lithiums. For example, we can represent these reactions in simple form in this way. The metal is in the elemental state, that is M, plus we can use the alkyl halides of X, so it gives RMgX. Here the X is ClBrI. These are ClBrI. So these methods are already discussed in various classes. And it's metal hydrocarbon reactions. Hydrocarbon reactions, such as synthesis of cyclopentadiene means NaCP. We can give the example. Sodium cyclopentadiene means it is called cyclopentadienyl sodium. So for example, this can be represented this way. Twice metal plus twice RH metal hydrocarbon reactions. So you can consider with twice metal plus twice RH gives twice Rm plus H2. Means here hydrocarbons loses hydrogen and produces this alkyl group, which is attached further to this metal, giving organometallic compound. Now the third, direct reaction of metal and carbon monoxide. So here carbon monoxide is carbonyl compounds of metals is separately already discussed part of this that is called organometallic compounds, but we are taking here the type of reaction only. So producing the metal carbonyl, so this gives metal carbonyls. For example, nickel and carbon monoxide gives nickel tetracarbonyl, that is NiCO4. So we have discussed this already, but this is generally represented as metal plus carbon monoxide gives MCO, and here this is N. So we have taken already the carbon. This is say nickel. These are 4 carbon monoxide gives NiCO4. So in the next method is D. Here the metal is taken in vapor phase. Metal vapor. Synthesis using vapor under high vacuum and high temperature. Under high temperature techniques. For example, we can see the metal in vapor state reacts with the substrate to give metal carbonyls. Organometallic compound, that is alkyl metals or metal alkyls. So these are the types of first, that is from elemental metals. These includes variety of reactions, but all these metals are collected or shown under this head, that is elemental metal is used in these reactions. So synthesis of metal, that is silicones, is the important element, that is organosilicon compounds. For example, organosilicon compounds. Organosilicon compounds. For example, the organosilicon compounds can be generally represented as R1, that is R Si, say X3, or that is say MESI Cl3, or we can see another R2 Si X2, R2 Si X2. For example, say Me2 Si Cl2, or we can take this R3 Si X, for example Me3 Si Cl. So these are some examples, or finally we can have these R4 Si, Me4 Si, tetramethyl silane. So these are a few examples which represent the organosilicon compounds, which are also prepared using the metal silicon. Now the synthesis by reactions. Synthesis by reactions. In this type of methods, the reactions are most commonly used to prepare the organometallic compounds are shown here as representative methods, and these are shown here as variety of types. So for example, one is exchange reactions. Exchange reactions. For example, there is exchange of certain part, that is, for example, we can take this metathesis of halides with alkylating reagents. Alkylating reagents. So these are represented here as MX plus R M prime. So if this metal is exchanged here with this, giving us a new product, that is RM, means this alkyl group and this metal, and M prime goes with MX, this X, giving M prime X. So this is a representative example. Here we have not used any specific compound or metal. Second type is metal halogen. B type is metal halogen or hydrogen. Metal halogen or hydrogen exchange. For example, means we can generally represent this as here Rn. This is alkyl means already prepared, means these are available in the market. You can obtain it from the industries which are supplying these organometallic compounds plus the R prime H, or we can use here R prime X. So here it can give this metal halogen exchange. This metal is exchanged with X or this H. So we can get this M R prime, that is R prime M, or we can show M R prime. Means both the things are same, plus RH. This H goes with this R. This H goes with this R. Or Rx. Means if we use this R prime X, it will give Rx. So this is the second type of method by which organometallic compounds can be prepared. Now, the C, addition reactions. Addition reactions. So these addition reactions are also variety of types. For example, such as means these are insertion, means either metal, means atom or a group is inserted between the metal and any other atom. That is a bond. Bond is broken, and the other atom or a group is inserted into that bond. For example, hydrometallation, carbometallation, then also oxymetallation, and carbonylation. For example, this can be represented shortly as RM, that is already available organometallic compounds as a reagent, plus A. So that will be atom or group which can be inserted between this R and M. So this A can be olefin or carbon monoxide, etc. Means there are other things also. So after insertion of this A in between the R and M, we get R, A, M or MAR. Means you can show it anyway. So this is general representation. Now the oxidative addition. Oxidative addition. Here, during this oxidative addition, the addition takes place with increase in the oxidation state of the metal. The addition of certain ligand takes place with the increasing oxidation state of the metal. So we can show here the example, that is a complex metal complex is say MLN. When the addition takes place, say of this molecule AB. So here AB can be, this can be RX or ester, etc. So after addition, when A and AB is added to this complex, the oxidation state of the metal is increased. Because of this, the metal here should be in lower oxidation state. Otherwise, we cannot get this oxidative addition product. So after all, it gives M. So A is one ligand, B is another ligand, and this already existing Ln. So here, if this is this is having monodentate ligand, this is also monodentate ligand, then the oxidation state of this metal will be increased by 2. So if it is already, this is say Ml4. So after addition, it will become Ml6. Decarbonylation. So this is E type of reaction, that is decarbonylation. Decarbonylation. Here the carbon monoxide group is removed. Carbon monoxide group is lost from the existing molecule. For example, this is represented as RCO. This CO is a ligand and this is attached to metal. This metal is attached to this carbon monoxide and this R. So after decarbonylation, the carbon monoxide is lost and we get this M plus carbon monoxide, that is released. Then next one is, that is beta hydrogen elimination. Beta hydrogen elimination. Beta hydrogen elimination. So say if we are having this compound, that is CH2 CH3 group, which is attached, let's say, to metal, or here, so if it is attached to metal. So after, this is alpha carbon and this is beta carbon. So beta hydrogen means one of this hydrogen is eliminated. So after this means minus H, we get M CH2 CH2, like this. Means the beta hydrogen is lost, for example, and this lost hydrogen is also coming here, means it is not fully given out. We can show this as into bracket, CH2 double bond CH2. Next type is anionic complex, formation of anionic complex. Anionic, that is ATE. Means the complex will, the name will end with ATE. Complex with carbanions, with carbanions, with carbanions. This is represented as metal M or N. Means this is the already available complex. When it reacts with, say, R prime, M prime, R prime, M prime. So it gives the product such as M is released plus this R goes with this mRNA. So we can show this as mRN. This is already existing, but this R is added to this complex. So we get this mRN plus this R, means additional R. So this we can show this R prime, and because of this this is anionic R. So the oxidation state is negative. Its charge on the complex is negative. So we obtain here an anion. So in this way, anion is formed, and with this we get new organometallic compound. The reductive carbonylation. This is H. Reductive carbonylation. Reductive carbonylation. Of metal oxides with carbon monoxide. So we can generally represent this as, here if we take the metal oxide such as MON, this is our metal oxide. And if we add to this a carbon monoxide, it is M carbon monoxides. So this M is added here, and here we obtain. So here we can obtain this CO2. So the carbon monoxide reacts with these oxygens. So we get n number of carbon dioxide, and this CO gets attached to this metal. So we get this metal carbon monoxide. So this metal carbon monoxide CO can be X. So the oxygen is removed, means reduction, and at the same time carbon monoxide is added. That is called reductive carbonylation. And for this purpose we are using metal oxide and carbon monoxide as the reagents. So in this way we can obtain also the metal organometallic compounds. And you see next stage, we can see electrochemical methods. Electrochemical methods. For preparing organometallic compounds in unusual oxidation state. Here, metal in unusual oxidation state. So this can be represented here as, if we take general representation, there is Rm, here Rm, and this complex is having oxidation state N plus. So here we can say complex organometallic, means this is organometallic complex is in available in this way. Rn, here the complex, the charge is not on M but it is on complex. So here we get this Rm with having charge N plus, and if we add to this electron, or if electron is removed from this, if the electron is lost by the metal, then oxidation state is changed. Charge on the complex is changed. So this is electrochemical process. So if we add this electron to this metal, we can obtain Rm N plus 1 plus charge. The charge on the metal will be this N plus, and this electron is added to this, then we will get different product. But when this electron is here with positive charge where electron is in this, one positive charge is added to the metal, it will give N plus 1 charge. This is or we can have this Rm is say when this electron is by E minus charge is added to this, the positive charge is decreased by 1 unit. So this will give us N minus 1 positive charge. N minus 1 positive charge on the complex. So this process is carried out by using electrochemical method. So these are the representative methods that we can study for the synthesis of organometallic compounds. So we will stop this discussion here, and in the next lecture we will see one by one the available methods for the synthesis of organometallic compounds. So the contents are very large, so we will see one by one. So thank you very much for watching. Please subscribe to this channel if not yet done. Also press the like button. So thank you very much, and visit this channel again.